Greetings. Do you know that this, not the wrench, but the rust on it, is the same thing as this? Now, they're both what's known as oxidation. This just happens to happen a lot slower than this. Everyone knows this, though. It's probably one of the most destructive and beneficial things on this planet that humans interact with. What I'm here today to tell you about is a few things dealing with fire. And I'm not claiming anyone is ignorant to what fire is, but just a little bit of the scientific aspect behind it. I'm going to cover what the fire tetrahedron is, which is essential for any fire to begin. The incident called pyrolysis, which is actually very unique when you look at something that burns. It's not actually the object burning, it's the gases that are given off by that object. And finally, I'm going to cover some fire behavior, just general fire behavior issues regarding that fire, what it is, and what happens to when certain things are applied or taken away. So as I begin, fire tetrahedron is essential for all fires. What it is it's oxygen all around us. It's a fuel, and in this case, it's a matchstick. That's going to be our fuel. You're going to need heat. I happen to have a candle here burning, so I don't have to mess anything up. But the candle is going to be my heat. It's going to be applied to the fuel, and it's going to combust into the oxygen. And ultimately, what you get and why it's called the fire tetrahedron is the fourth element, which is the self-sustained chemical reaction. When all of those elements come together, fire will burn. Fire will also burn until one of those are taken away. In this this example is oxygen. In just a matter of seconds, the fire's been extinguished. Now this goes for the other ones as well. If you remove the fuel from the fire again. If you remove the fuel, say I remove it partially, just a demonstration, eventually the fire will go out because it will run out of fuel. I'm not going to burn myself. The final is to cool it. And this is what everyone should know as. You would take in essence, what happened there is there's a certain temperature needed for this to burn. And by me blowing on it, my breath is actually cooler than the temperature needed to burn. So I've actually exhausted the fire by what you think is you're actually removing the flame, but it's more than that. You're actually cooling the temperature down below the point in which it will burn. All those elements together is known as the fire tetrahedron. Now, as important as that is a little bit about how fire is and what actually happens to the object. Everything burns. Believe it or not, concrete will burn if it gets hot enough. It might be crazy to think, but keep that in mind. Anything will burn. In order for pyrolysis to happen, you have to have a reducing agent. In this case, once again, it's our brother matchstick out of his friends. And I want to show you something very interesting with this. Once I get it going. I got to get the flame going pretty good for you to really see it. But what is really cool, bear with me, I apologize. There we are. I don't know if you can see it that well, but when I give it a second, when it starts burning along, there's actually a distance between the visible flame you see and the matchstick. That area is clear, and what happens is the heat is actually causing the wood to break down. And when this wood breaks down, gases are given off. The same in essence of when you boil water. When it gets to a certain temperature, it releases it off gases. It gets rid of its vapor density. Same thing happens with solid matter too. Once it gets hot enough, it will start releasing components of itself. It will break down and release your carbon. And I'm not going to get too much into the specific scientific aspect, more than just keep in mind that when something breaks down, whatever it is, the gases that gives off by the heat is actually what burns. And the heat continues to make the object give off more gas, and in turn the fire gets bigger, and you can kind of see where this is going. Now, fire behavior, once again, I kind of alluded to already. If you take away some of these components to fire, it will extinguish any one of those four specifically. What is unique about fire behavior is the light, the visible light and the heat from the fire is just like the sun's rays that you see around you. It moves at the speed of light, which in essence heat transfers in the distance it takes for fire, for the light and the heat from a fire is instantaneous, at least on our perspective on Earth. You have two matchsticks together, burn, and they went out on me. But in essence, two matchsticks will burn 4 times hotter than one matchstick. And you can kind of see where this is going and why fires increase so rapidly. A fire will duplicate in size every 30 seconds. This means that if you had a couch, just a love seat, a two cushion couch, and you had one couch or one cushion burning, within 90 seconds that entire couch would be completely consumed by fire. It's crazy how fire just wants to continue, and it will burn whatever it can get a hold of in order to continue. It almost makes you think that it's a living thing. So to sum all this up, everything I've covered with you today is the fire tetrahedron, and what is important about that every fire that you see encompasses that fire tetrahedron that I spoke of. Paralysis, every single thing that burns undergoes that change of chemistry into paralysis. And what's left over from that I didn't mention before is char. When you see char, that's the remaining element of the carbon that's left over from the burning process. And finally, fire behavior. And most of this you may already know, but it's just to kind of open your mind a little bit and see that if you understand it a little bit better, it might be easier for you to control or get a grip on what specifically fire is. I thank you for your time.